Hey everyone, today we'll be going over LeetCode problem 2, add two numbers. In this problem, we are given two linked lists, and these linked lists represent two non-negative integers. These digits are stored in reversed order, and what we want to do is sum these digits and return the sum as a linked list. Now keep in mind that each node contains a single digit. So I've created an example here for you guys, and we have two numbers. We have L1, the first list, which represents the number 2584, and L2, which represents the number 643. Now we are told that each node contains a single digit, and that these digits are stored in reverse order. In fact, in 2584, the last number is a 4, and therefore the head of L1 is the 4. Whereas the 2, which is at the end of the list, is at the beginning of the number 2584. So what we want to do is go through these two lists, sum the numbers, and return the result as a linked list itself. Now we know that when we go and sum two numbers, we're going to start by summing the ones place. Say for example, if we sum 2584 plus 643. We know that first we would add the 3 to the 4 and get 7, and we know that 7 is in the ones place of the result. We would then go on and sum the 4 plus 8, and we know that we'd get 2 and a carry of 1. And then we'd sum the 6 plus 5, getting 11. With the carry of 1, we get 12. So we get 2 and another carry of 1. And then at the end, we will add the 1 with the 2 to get 3,227. Now, because these digits are stored in reversed order along these linked lists, this makes the process easier. In fact, we could just start from the head and go and do the sums like we would do normally with the ones place. So we have here, for example, a 4 and a 3. We know that summing them, we get 7. So we go and put that as the first node in our new linked list. We then move on for the next digit. We know that 4 plus 8 is equal to 12. So when we have 12 as the sum, we need to decide what number to put into our node and what number to keep as our carry. Now when we have 12, we know that if we do an integer division by 10, we will get 1 as our result, and we know that therefore that will be our carry. Instead, when dividing by 10, 12 will have a remainder of 2. So by doing the modulo operation, we will get the current node's value. Therefore, we will go and put our 2 into our node and keep the 1 as our carry. We then add the 1 from the carry plus 5 plus 6, and we get 12 once again. So again, we can put 2 as the new value of the next node, and 1 is our carry. And then what we could do is we have our last carry of 1. We add that with the 2 and get 3. And when going to check our second linked list, we know that it's done. So we would just have a symbolic 0 here because we're summing with nothing. So therefore, for our last node, we get 3 as the value. And this is how we get our result of 3,227 stored in reverse order. And we would need to return this node with the 7 as our head. We see that this algorithm is linear in time complexity. It is O of n, where n is the length of the longer list. And this is because we have to go along until we end with the longest list that's given to us. And space complexity is O of 1 because we are not using any additional data structures besides the length that we're using to return the response, the output itself. Now we have to take care of another edge case besides the one where one list is longer than the other. In fact, say we have, for example, these two lists representing 5 and 6. When we go and sum the 5 plus the 6, we know that we would have 1 as our new value and a carry of 1. However, the two lists are done. But even though the two lists are done, our algorithm is not done. In fact, we must not forget the carry. Therefore, we will need another node to put in this last one from the carry. And because of this one, our result becomes 11. So we need to not forget that even though when we're done with the two lists, we must still check to make sure we do not have a carry. Because if we do, we must add that carry as our final node. We're going to start off our code by creating a dummy node. And this dummy node is going to be an empty list node, which will help us take care of many of the edge cases which comes with creating new linked lists. So we're going to take a current pointer and equal it to the dummy, and we just need to remember that at the end we're going to be returning dummy.next as the head of our actual linked list representing the new number. Then we're going to take our carry initially set to 0, and then we want to start iterating through these lists. So while at least list 1 or list 2 still has more digits, we want to check to see if the first list has a digit, and if it still has a digit, it's not completed, we want to take that value. So we could take value 1 to be equal to L1 that value. And instead, if L1 has been completed and has no more digits, then we could take value 1 to be equal to 0. We're going to do the same thing for list 2. So if it has another digit, we'll take value 2 to be equal to L2 that value. And if not, we could just make it equal to 0. And then we're going to compute our sum. So we know that our sum is going to be equal to value 1 plus value 2 plus the carry if we have one. We're going to take our new digit, and our new digit we said is going to be equal to the sum modulo by 10, so the remainder of the division by 10. And then we're going to take our carry. So we said that our carry instead is going to be equal to the sum integer division by 10. We're going to then set the next value in our list to be equal to a new list node with this new digit that we just found. Then we want to move on along our new list, so we're going to set cur equal to cur.next to move the pointer. And if list 1 is still not done, then what we want to do is make list 1 equal to list 1.next. So we're going to move the pointer along for list 1, and we're going to do the same thing for list 2, as long as they are not done. Once we're done with the while loop, which means that both L1 and L2 have been completed here, then what we could do is just make sure that we do not have a carry. Because if we do have a carry, we said we need to take care of that edge case. And if we have a carry, we're going to make another list node with its value equal to the carry. And at the end, we need to return dummy.next, because remember, dummy was the empty list node with no value. Let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.